Welcome to Brain Vision.
Problem 11.53 is about leg raises. So we have a simplified model of the musculature involved with raising one's leg while you're lying down. The abdominal muscles are roughly horizontal and join the femur at an angle of about 5 degrees when the leg is horizontal. And it pivots about the hip joint there. We're saying that they attach 10 centimeters from that joint all in one point. This is not true in a real human body, but for the sake of having a tractable problem, we assume that. This person has a mass of 80 kilograms, their legs are 90 centimeters long, and have a mass of 15 kilograms with a center of mass 44 centimeters from this joint. So we'd like to consider the leg being raised to 60 degrees. We want to find the tension in the abdominal muscles and draw a free body diagram of the leg. Then we want to answer whether the tension is greater at 60 degrees or when the leg is horizontal right as you're lifting it. And then if the muscles were completely horizontal, would they be able to raise the leg? So let's go ahead and get started. So we want to use the equilibrium condition where the sum of the torques is equal to 0. So we have the tension in the muscle times its moment arm, 10 centimeters, times the sine of the angle theta. And then that's going to have subtracted from it the weight of the leg times the position of its center of mass, 44 centimeters, times the cosine of theta. And so then the tension, if we solve this, is going to be 4.4 times the weight of the leg times the cosine of theta divided by the sine of theta, so 4.4 times the weight times the cotangent of theta. Now for theta being 60 degrees, this means that the tension will be 370 newtons. And a free body diagram of this looks something like so. We have the pivot at the hip, and now there's going to be forces here that we're going to not draw in because we don't know what they are and we don't care for this problem. There's going to be the weight of the leg, and then the tension of the muscles. This is going to be located 10 centimeters along. This is going to be located 44 centimeters along. And this makes an angle theta. So using our expression here, we can see that when theta is 5 degrees, like it is when the leg is lowered, that the tension is going to be 7,400 newtons. And so this is a lot more than when the leg is at a 60-degree angle. And that's going to be because this angle is smaller, and so the sine of the angle will also be smaller. And so the muscle has to exert more force because of the the cross product depends on the sine of the angle. And it has to exert more force in order to, produce the same torque, I should say. So it's greater when the leg is horizontal and you're just lifting it. And if you lie down and try to lift your leg, you'll find that it requires more effort to get it up from horizontal than it does to hold it some greater angle. And the answer to part C is going to be no, because if you have some object that's pivoting about a pivot and you apply a force anywhere along it that's parallel or anti-parallel with the displacement from the pivot, then the cross product is zero, and so there can't be any torque.